All right, well, welcome back. Another demonstration of the ECU, another test, second test. I swear to you, I haven't done another test since the first video. I've done a few modifications, and we'll go over those in a moment. Very simple stuff. Pretty cold in the garage here today, actually. It's about 4 degrees Celsius. If only I had a Chinese diesel heater or a drip feed oil burner. Diesel heater, oil burner. But no, it's pretty cold in the garage. Interestingly, okay, first things first. Don't do any of this crap at home. Don't blow yourselves up. Don't burn your house down. Use your Chinese diesel heater exactly how it's intended. I do this shit. I'm a little bit stupid, but I'm quite confident in what I'm doing. If you want to do it yourself, that's your decision. Please don't be influenced by me and do anything horrible to yourself or your family or your house or your property or your camper or your caravan or your garage, all that crap. Please just use your Chinese diesel heater how it was intended. Follow the instruction book, if you can read it, that is, because mine made no sense whatsoever in Chinglish. But there you are. Okay, just to recap, we did a test a couple of days ago, and for some reason the pulse generator was pumping the pump really erratically. It had not a lot of adjustment on the front. It certainly wasn't working how it worked when I had it in the kitchen. I wasn't sure why that was. I thought it was because I'd probably knocked a wire off or a connection on one of the multi-term pots. However, today I came out and had a little play around, quite expecting to see a solder joint pulled to pieces or something, because it's all sort of mashed together. And there was nothing. It all seemed to be okay. So I powered it up, and the pump went click once and just stayed on, which is really odd. The control panel, the pot on the front control panel made no difference whatsoever. So I started tweaking the pots, and I quickly realised that if I adjusted the potentiometer, which supposedly adjusts the duty cycle, I could get it to work again, playing around with that multi-turn 10k pot. I think I know why. These boards are incredibly cheap. I think the pulse generator board is probably on sale for about £2.50 or maybe even less. They're built as cheap, and in fairness to the write-up, it does say that there's a lot of interaction between the frequency potentiometer and the duty cycle potentiometer. So what I think is happening is that it's so cold out here. So if you remember, when I had it on the bench in the kitchen, on the kitchen side there, it was about 17 degrees Celsius. When we come out to the garage the other day, it was sort of not behaving right at all, and it was about 11 degrees Celsius in the garage, I think, from memory, 11 or 12. Today I came out and it was sort of hovering around 3 or 4, and it wouldn't even fire up. I think it's because it uses a very simple resistor capacitive network for the timing components. I think they're susceptible to temperature variations. So what I think we're going to have to do, I think I'm going to have to build a little pulse generator board. I'll have a look around first of all, see what's available, but I probably ain't going to end up having to build one to do exactly what I want it to do. I don't think these cheap off-the-shelf stuff, which is really designed for Arduinos and Raspberry Pis, I don't think they're going to be any good for what I want to do. Not stable enough anyway. So what I've done is, you'll see from the video in a moment or two, which I'm going to post up as picture-in-picture, hopefully, if my editing skills are up to it. You'll see that I've managed to get a rough average of between sort of like 20 and 30% on cycle, between a frequency range of sort of 1 Hertz and 10 Hertz, which will be okay for this test. I'm going to run another test, so I'm just going to spin you around. Okay, so you'll also notice that I have added another switch here. The purpose of this switch is to assist the close down. So I've been thinking about ways of doing it, and I was going to put another timer board in when we close it down. So the idea was it would bring the glow plug on again for a few seconds or half a minute maybe, and switch the pump off, which is roughly how the stock ECU does it. But that meant putting another timer board in, and the whole point of this is to try and keep it as simple as possible. So I figured that if I put this simple switch in line with the fuel pump, the dosing pump, I should be able to just isolate the pump, kill the fuel pumping into it, and it should just then burn off any fuel what's left. So we'll give that a try in a minute. So it's literally just a toggle switch in line with the pulse generator supply and the MOSFET supply, driver supply. So that will just literally knock the pump off when we're ready to close it down. What else? I have adjusted the thermostat. So let me just get my little doobry. So I've adjusted the thermostat, and now it should switch at 50 degrees C. There we go. So it's 7.7 right there at the moment out here. Been out here a little while now, and it's starting to warm up. Now the sun's come outside, it's started to warm up a little bit. What else have I done since the last test? Okay, I've been and got some clean white diesel and filled our little reservoir up with clean diesel. I've also purged the fuel line and dosing pump. I'm running on a car battery at the moment because I'm using the other battery we used last time, and the charger I'm using that for the diesel heater in the house at the moment, which is actually running. If we're nice and quiet above the traffic noise, you should be able to hear it. Let's open up. There we go, you can probably hear that there. So, okay, so we're going to start the test once again. So, power on, and we have ignition. The first green LED tells me that the glow plug is now active. And in about a minute or so, we should start seeing, we should see this LED come on, which will and then that in turn should start the fan running and the dosing pump. Well, we failed at the first hurdle because the dosing pump isn't dosing, so we're going to have to close it down. So I've just reset it, and let's see if we can work out what's going on. My priming pump is working, my priming button is working. Right, there we go. Right, got a problem. Just going to switch the video off and I'll have a look and come back to you. Okay, so we're back. We're charging the battery up. The problem was I only had 7 or 8 volts getting up to the controller under load. Obviously a couple of rounds with the glow plug was enough to finish a battery off. I have used this battery quite a bit recently for various bits and pieces, jump starting cars and God knows what else, and I'd underestimated how flat it was. Obviously the cold temperature in here in the garage was enough just to kill it off. It was a really old battery. It was on my old X5 E53. It's about, I don't know, 10 years old, and in the summer I'd left the fridge plugged in. We drove out to Romania. I left the fridge plugged in and overnight, and it completely flattened it, and I ended up having to buy a new battery while I was out there to get us home. And I brought this one back with me, put it on a repair cycle on the charger, and it seemed to be okay, but I suspect it's had better days. Anyway, it's been on charge for a while now, probably 5 to 10 minutes, so it's now probably okay to try again. So let's try again. We've switched it on, press the first button, which should bring the glow plug on. Green LED is telling me that the glow plug is on. In a minute or two come on. Blimey. Turn the fan down a bit. Pump's pumping this time. Fair bit of air in that pipe. I think we've got more air getting into it than we have fuel actually. Yeah, not got enough fuel getting into there. Got way too much air in that fuel system, which I think I'm going to have to address. We're still running on the timer at the moment. We've only got 34 degrees on the thermostat. No. So there you are. That was a bit of a failure really. I think that's down to the amount of air there was in that fuel system. So basically the thermostat got to 35 degrees measured at the outlet, and it didn't get up to temperature enough to latch in and carry on running it. So I'm going to pause the video. I'm going to get rid of some of that air in the fuel system and we'll try again. Right, so I've purged the fuel system a bit, repositioned the fuel pump, and we'll try again. So green LED telling us that the glow plug is glowing. Whoa! Too much fan speed. Now what I don't understand, yes I do, I upped it to 50, so in a minute the other LED should come on. It didn't. Excellent. Oh, there we go. So the other LEDs come on to tell us that the thermostat has clicked in. Producing bags of heat now at the outlet. Bags and bags of heat. So there we go, it's running. Also evidence, boys, of course, that you should always have the pump running the right way. As in, the angle of a pump is relatively critical. How I had it before was rubbish. So the timer boards have now timed out and been running on the thermostat. Loads of heat coming out of there. Quite a clean burn at the moment, by the looks of it. Right, I've just upped the fuel rate. Time to open the garage doors a little bit. Right, we're chuffing out a bit of black smoke there now. Slow the pump rate down. Whoa. Instead of pump rate down, we'll do fan rate up. Go, that's cleared up the smoke now. Just reducing the fan rate slightly, the pump rate slightly, and bringing the fan rate up. 90. Fuck me, that's hot. Just move the thermostat slightly, thermocouple. Oh! Wasn't happy there, boys. I don't know what happened then. Looks like we flooded it. Oh! No, it's not what I thought it was going to be. Right, now something. Why has the fan died? Interesting. So the fan has died. We're still on the timer. Right, anyway. I've turned the pump off. I'm not sure why the fan has stopped running. Maybe I've killed the fan, I hope not. But it's cooling down quite quickly. So it looks like the fan died, or for some reason stopped running, and then it carried on pumping for a bit, flooded it, and it's gone out. That was the thermostat just clicking off then at 50 degrees Celsius. Right, so clearly a bit more work to do, but we are getting there. That was a slightly more promising test from last time. I'll come back in a second or two. Aha, back again. So, some of you probably thought that I blew the fan motor up. Or maybe you thought my battery voltage had dropped again. It was none of those things at all. It was actually the fan motor driver board I'd used. So I'd underestimated how much current the fan motor drew. My fault, I should have looked into that maybe. Underestimated how much current the fan motor drew, and it's cooked the MOSFET on the motor board. So there's the motor driver board there, and there's the power FET, and I haven't done it any favours at all. It still sort of works, but it starts to get hot and then breaks down. So I have got another fan controller board. It's a board I bought for this actually when I had in mind doing it. It's one here, meant to be able, it's got a heatsink on it. It's meant to be able to control considerable more power, much more power than that other one. So my next thing to do is change the controller board, and we'll come back to it and have another go. But thanks very much for watching. This is test number 2. Ironed out a couple of little problems, or worked out what's going on with the pulse generator, and know I need to improve on that. And now we need to look at this fan controller. I'm glad I haven't blown the fan up in the heater though. That's what I thought, that I'd killed the fan in the heater, fan motor, but I haven't, which is good. It's always good. Okay, well, thanks very much for viewing. If you like what you've seen today, please give a thumbs up and hit the like button, and if you haven't already subscribed, please subscribe. It does help me. Thank you very much indeed, and look forward to another installment quite soon.